The last of the little examples are when we're using our radical sign. And we spoke about in surds how we can have the square root of something or the cube root of something. We can also write that as an index. And so for us, we normally write the square root of 4. That's the same as anything to the power of a half. Now the square root by default means we've got a little subscript 2, just there to give you an idea of what nth root we're trying to get. All right. If I want a cube root, the cube root of 8, in other words, a times a times a is equal to something, and that's equal to 2. All right. Now, if I want to write these as fractions, that's the same as 8 to the power of 1/3. Okay, so the little n there at the square root sign tells you what denominator we need to put into the power of the fraction. And if on the inside of under our radical sign we have a number raised to a power, that'll go in the numerator. All right, so we can see that there with the example. 4 to the power of 3 on 2. Well, the 2 is in the denominator, so it goes out the front. The 4 is to the power of 3, so that goes under the square root. 4 cubed is 64, and the square root of 64 is 8. So as 4 to the power of 3 on 2 is a really messy looking number, but in actual fact it turns out to be 8. So in terms of simplifying, just remember that if we have a radical sign, we're going to be raising our indices typically to a fraction of some sort. So again, we check all of our bases are a. So a to the minus 1 is a minus 1. The square root of a is a to the half. The fourth root of a is a to the 1/4. All right, so then what I typically do is I write everything is with the same denominators. So because we add and subtract fractions at the same denominator. So -1 is -4 on 4, a half is 2 on 4, and a quarter is a quarter. If we add all those together, we get a to the power of -1/4. Acceptable answer, but we want a positive index, so we might write it as 1 over a to the power of 1/4. We could in turn then turn it back into an expression involving the radical sign. Okay, so have a look at that and hopefully that makes a little bit of sense. But my calculator will stop here at 1/4. Example 2, a to the power of 1/4, square root of a we've already spoken about is a half, divided by, so in the denominator, and the cube root of a is a to the power of 1/3. So again, I've turned all the fractions into 12ths because there's my lowest common denominator. So 1/4 is 3 on 12, a half is 6 on 12, and the 1/3 on the bottom is 4 on 12. 3 plus 6 is 9, minus 4 is 5. So I get 5/12ths there as my power. All right. If we have numbers that we need to work with, and that's what C and D are, try to write each of the numbers in their simplest base form. Remember in year 7 we did a thing called prime decomposition. Okay, and we just tried to write every number down to a product of prime numbers. So look to do that. 16 is the same as 2 to the 4. 8 is 2 cubed. There's my 16 again, which is still 2 to the 4, and my 16 again, which is 2 to the 4. So I've just written each of the numbers there in their simplest, with this smallest base number. Now I'm going to apply my index laws. 2 to the power of 4 times to the power of 1/4, we multiply that, so 4 times 1/4 is 1. 3 times a half is 3 on 2. 4 times 1/4 is also 1. And 4 times 3/4, well 4 times 3 is 12 over 4 is 3. So you can see there on the right hand side, all of my numbers have got a base 2, so I can now add and subtract all the indices. So 1 plus 1 plus 3 on 2, well that's 1 plus 2, 3.5. 3.5 over or minus 3 will give me a half left over, so I get a 2 to the half, and 2 to the half is the same as the square root of 2. All right. Finally, go through it again. 32, nice one. That's 2 to the power of 5. 12, I've broken it out a bit. That's the square root of 4 times the square root of 3. Okay, so let's remember some of our surd stuff. The cube root of 12 is the cube root of 4 times the cube root of 3. So if I group, and 16 on the denominator is 2 to the 4 to the power of a quarter. So 2 to the power of 5 times a quarter is 5 on 4. The square root of 4 is just 2, or 2 to the 1. The square root of 3 is 3 to the half. The cube root of 4, well, that's the cube root of 2 squared. So there's my 2 squared, and there's my little on 3 to make it a cube root. And then the cube root of 3 is just 3 to the 1/3. Okay, all over 2 to the 4 to the power of a quarter, which is my 2 to the 1. So I've got 4s, 2s, and 3s. So I made everything in terms of a denominator of 12. So 5 on 4 is 15 on 12. 1 is 12 on 12. And 2/3 is 8 on 12. My 3s, I've got a half, which is 3 on 6, plus a third, which is 2 on 6, all over 2 to the 12 on 12, just to make them all 12ths. So I've got common base. So adding the powers, 15 plus 12 plus 8 is 35 over 12 on 12. So I subtract that, gives me a 23 on 12. 3, 6 plus 2, 6 is 5, 6. And so that's a reasonable sort of answer. The 23 on 12, I could write as 1 plus 11 twelfths. So there's my 2 to the 1 there, and there's my 11 twelfths there. And that matches off to our CAS. Okay.